Students, in continuation with chapter Surface Chemistry, today we shall be studying about Freundlich adsorption isotherm. Freundlich adsorption isotherm, actually, it is a variation, it is a graph first of all. It is a graph showing the variation in the amount of gas adsorbed by the adsorbent with pressure at a constant temperature. And Freundlich adsorption isotherm is an empirical relationship between the quantity of the gas adsorbed by a unit mass of solid adsorbent and pressure at a particular temperature. The validity of the Freundlich can be verified by plotting log x by m on y-axis and log p on x-axis. If it comes to be a straight line, it means that isotherm is valid. It means the extent of adsorption on a given surface generally increases with the increase in pressure, and the concentration at a constant temperature. At low temperature, the physical adsorption of the gas increases very rapidly as the pressure rises. When the temperature is high, the increase in adsorption is relatively less. And at low value of P, when the pressure is low, the graph is nearly a straight line and sloping. When the pressure is high, x by m becomes independent of value of pressure. And in the intermediate range of pressure, the x by m will depend on the pressure to the power between 1 to 0, that is fraction. So Freundlich adsorption isotherm can be written as x by m is equal to kp power 1 by n, where n is greater than 1, where x is the mass of the gas adsorbed on the mass m, that is m is the mass of the adsorbent at pressure P. K and n are constant, which depends on the nature of the adsorbent and the gas at a particular temperature. The relationship is generally represented in the form of curve, which you all have seen in the last slide. The mass of the gas adsorbed per gram of adsorbent is plotted against pressure. The curve indicates that at fixed pressure, there is a decrease in the physical adsorption with increase in temperature. These curves always seems to approach saturation at a high pressure. So we can write the above expression. If we take the log on both the side of the equation, we can write log x by m is equal to log k plus 1 by n log p. So you can see the graph here. The graph is plotted between log x by m and log p. Here at low pressure n is equal to 1. So x by m will be equal to kp. At high pressure n is greater than 1, that is x by m is equal to k, that is independent of p. We have already discussed this, that if we take the logarithm on both the side of the equation, we'll be getting the expression that is log x by m is equal to log k plus 1 by n log p. Now the adsorption from the solution phase. In case of adsorption from the solution phase, the extent of adsorption decreases with the increase in temperature. The extent of adsorption increases with the increase in the surface area of the adsorbent. The extent of adsorption depends on the concentration of the solute in the solution. The extent of adsorption also depends on the nature of the adsorbent and adsorbate. So expression can be written as x by m is equal to k c raised to the power 1 by n. What is c here? C is the equilibrium concentration. And same way, if we'll take the log on the both the side of the equation, we'll be getting the expression log x by m is equal to log k plus 1 by n log c. Now, what are the applications of adsorption? Very important topic. That where do we find the adsorption is going on or adsorption is taking place? So, few examples I have shown here, like in gas mask. Gas mask, a device which consists of activated charcoal or the mixture of adsorbent, is used for breathing in coal mines to absorb the poisonous gases. Silica gel and aluminium gel are used as a adsorbent for removing the moisture and for controlling the humidity. Heterogeneous catalysis. Heterogeneous catalysis means the adsorption of reactant on the solid surface of the catalyst, which increases the rate of the reaction. Due to the difference in the degree of adsorption of the gases by the charcoal, the mixture of noble gases can be separated by the adsorption on the coconut charcoal at different temperature. Very important point, that adsorption can also be used to cure diseases. A number of drugs are used to kill germs by getting adsorbed on them. Even in metallurgy, in froth flotation process, the adsorption process takes place. A low-grade sulfide ore is concentrated by separating it from silica and other impurities by using the pine oil and the frothing agent. Adsorption indicators like eosine and fluorescein are used. The surfaces of the certain precipitates such as silver halide have the property of adsorbing some dyes like eosine and fluorescein, and thereby producing a characteristic color at the end point. Chromatographic analysis. Chromatographic analysis based on the phenomena of adsorption find a number of applications in analytical and the industrial field. Now, catalysis. You all know about the catalyst. Catalyst is a substance which can change the speed of a chemical reaction without itself undergoing any change in mass or chemical composition at the end of the reaction, and the phenomena is known as catalysis. Catalysis can be divided into two categories. One is homogeneous catalysis and second is heterogeneous catalysis. Homogeneous catalysis, if the catalyst is present in the same phase as the reactant, it is known as the homogeneous catalysis. One example I have taken here, that sulfur dioxide is gas, oxygen is gas, and catalyst, that is NO, which is used, is also gas. And the product formed is sulfur trioxide, which is also gas. It means reactant and products are in the same physical state. Another example we can show, like methyl acetate is liquid. When water is added in the presence of HCl, catalyst, HCl is also a liquid. The product formed are ethanoic acid and methanol, and ethanoic acid and methanol are also in the liquid state. Heterogeneous catalysis. In heterogeneous catalysis, the catalyst, reactant and product are in the different physical state. So the catalyst is present. In this case, the catalyst is present in the different phase than that of the reactant. Example, very common example I have taken here, that is nitrogen is gas, hydrogen is gas, but here the catalyst uses iron, which is in the solid state. So the phase is solid and the product formed is ammonia, again it is gas. Even one more example we can give here, that is sulfur dioxide gas. When oxidized in the presence of oxygen, it forms sulfur trioxide. Sulfur trioxide is also gas, but here the catalyst uses platinum, which is solid. Now, what are the characteristics of catalyst? Catalysts remain unchanged in mass and the chemical composition. In case of reversible reaction, the catalyst does not influence the composition of the reaction mixture at equilibrium. only it helps in attaining the equilibrium quickly. Now there are two new terms I have written here, that is promoter and poison. What are promoters? Promoter is a substance, if present along with the catalyst, it enhances the activity of the catalyst and it is called the catalytic promoter. For example, molybdenum acts as a promoter for iron catalyst in the manufacture of ammonia by the Haber's process. What is catalytic poison? Certain substances like arsenic, carbon monoxide, etc., if present, lower the activity of the catalyst, and these substances are called the catalytic poisons. Now the important features of the solid catalyst. What are the important features of the solid catalyst? First is activity. The activity of the catalyst depends upon strength of chemisorption to a large extent. The adsorption should be reasonably strong, but not strong that they become immobile and no space is available for the other reactant to get absorbed. Second is selectivity. Selectivity of the catalyst is its ability to direct a reaction to yield a particular product, but under the different catalyst. When the different catalysts are used, the product formed are different. Like one example we have shown here, that carbon monoxide, when made to react with hydrogen in the presence of nickel catalyst, the product formed is methane and water. And same reaction when carried out in the presence of copper and zinc oxide and chromium oxide, the product form is different, that is methanol. Even carbon monoxide, when made to react with hydrogen in the presence of copper catalyst, it forms methanol. Now the adsorption theory of heterogeneous catalysis. Heterogeneous catalysis. Now you know what is heterogeneous catalysis. When the catalyst and the reactant and products are in the different phases or in the different physical state. According to the old adsorption theory of heterogeneous, it was believed that the reactant in the gaseous state or from the solution are adsorbed on the surface of the catalyst. As a result, the concentration of the reactant molecules on the surface increases and hence the rate of the reaction increases. But the modern adsorption theory is a combination of old adsorption theory and intermediate compound formation theory. And according to this intermediate compound formation theory, the reactant, suppose there are two reactants A and B, which first combined with catalyst C to form an intermediate complex, which then decomposes to form the product and regenerate the catalyst. Now we'll see what are the important features of modern adsorption theory. The first point is that is the diffusion of the reactant molecules towards the surface of the catalyst. Second is adsorption of the reactant molecules on the surface of the catalyst by forming a loose bond with the catalyst due to the presence of free valencies. Next is the occurrence of a chemical reaction on the catalyst surface through the formation of an intermediate. Then is desorption of the product from the catalyst surface. And the last is the diffusion of the reaction products away from the catalyst surface. Here we have shown with the diagram that this is the catalyst, A and B are the reactant, A and B are adsorbed on the catalyst, then even A and B form the bond, so intermediate is formed. This intermediate is then dissolved. Desorption of the product molecule takes place and catalyst is regenerated and the product formed is A and B. So in this chapter we have today studied about the Freundlich adsorption isotherm and catalysis. Thank you.